Let's see today's problem. It says that on election day, a voting machine writes data in the form voter ID, comma, candidate ID to a text file. Write a program that reads this file as a stream, okay, and returns the top three candidates at any given time. If you find a voter voting more than once, report this as a fraud. Okay, so this content would be continuously being written into a text file. So that would be the first step. We need to read this as a stream. We can't read it a whole because it's running at the same time. Okay. It returns as the top three candidates, and also we are supposed to keep track of if one voter has more than one entry in our list, then it would be considered as a fraud. Okay, so if we go with that logic, the number of so in this voter problem we would have number one is read as stream, right? We need to read it as a stream. Fine, so stream. Okay, and second way for us to keep track of the each voter ID, right? So that if you receive it once again, it means it's a fraud and stop. Okay, to check for fraud, and the third one is always we need to keep track of the top three candidates, candidate IDs, candidate 1, candidate 2, and candidate 3, right? So we need to keep track of the top three candidate IDs, right? This makes sense. Anything else? Candidates at any given time, you need to find the voter ID. Okay, so let's say we keep iterating for line in a file, keep reading the content of the file and line by line. As we get the line, we need to parse the line, and so this would be parsing step, right? We would need to parse the line, separate it from, like we would have voter ID and candidate ID, right? So we would need to like capture that data first of all, candidate ID. Okay, we would be able to first parse this, store this. So approach would be, we could how do we resolve this? This can be solved by, let's say, to begin with, right? We could always begin with, we'll start with one map, right? The map would keep containing, do we need a map? Actually, we could, since we are using Python, we can always put it in a set only. Now we'll put it in a set. That way, do we need to put it in a set? Yeah, we can have it in a set or a list also, because if it duplicates, then obviously it would fail, right? Nope. If we keep it in a set, right? If we keep all the voter IDs in a set, yeah, that would make sense. So how would we proceed with this? Is something like let's start with the first logic. We would go with let's say that, where's brush? Yeah, so we'll have a map which keeps track of the candidates and their scores, right? Candidate 1, and these are the number of votes, like 4, candidate 2 6, candidate 3 7. Like this, will keep track of it. We'll maintain another array of size 3, which is always going to keep the top 3 candidate IDs, right? Can we only store those? Yeah, we can. No, if we store only the candidate ID of the top 3, candidate 1, candidate 2, candidate 3. Now, when I get another new candidate who's having more voting, I would need to increment and check if any of this is greater. If so, yeah, I think we can do that. We'll come to that. How to get the top 3, we will address it in But if we keep storing all the candidates and their scores over here, we would be able to do this. And we can store all the voter information in a list or a set, right? Just put all the voter IDs in a set, and uh, before parsing it and adding the vote, we need to always check whether that voter ID is already in our list or set. Think set is, I mean, list would be easier. It's just simple append, and if it is there, we need to just check if in. It would not be very optimal, but yes, we would check if it is in the list. If it is in the list, then throw an error. If it's not in the list, then proceed. Correct, right? So for the candidate, we would store it in the map, right? Hash map over here for candidate values. We would store it in a hash map. Voter IDs, we would store it in a list, right? Voter IDs. How would we get the top three? I think if we have a list which keeps track of the top three candidates, candidate 1, 2, and 3, I think that should be sufficient. I think this we can do. Yeah, I think it is feasible without just using these in a pass. Okay, so let's get started with the problem then. Let's copy it down. Right, we can create a new prompt. Python with the question. Election day, a voting machine writes data to text file. Write a program that reads the information as a stream. This would be part 1, and returns the top 3 candidates at any given time. And if you find a voter voting more than once, report this as a fraud. Okay, so step 1 is we need some sample data. So what we will do is we need to have a folder election, we call it as vote voter txt, right? So this would be like, we will go with the conflict v1. So we have v1 comma candidate id is c. Okay, we'll call it as voter1, right? Candidate 1. So assume that we have this, right? Now we can have 2, 3, 4, 6, 7, 8, 9, and again 1. This should throw an error in this case, right? And then we go to here, right? This would be 11. Okay, so we'll have candidate 1, 2, 2, 3, 2, 1, 3, 5, 5, 5. This is just arbitrary. I'm just adding it so that I get more values, right? I think 5 will be in the top. 1, 2, 3, 4, 5, 6. Okay, so 30, 40, 50. Okay, so we have, as of now, we have candidate 5 with 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 votes. 3 would be leading next with 1, 2, 3 votes. 2 would have 1, 2 votes, and then 1 also has 2 votes. Okay, so now we can, oh, think voter 5 is copied a couple of times, right? So we will cut this part, come back here, and we'll give it to voter no, not right. So one has more votes. This would be 16. This would be 17, right? So now how would this table look? One has one candidate one, right? If you search for this, we have 1 2 3 4 4 votes for candidate 1. Candidate 2 has only 1 2 2 votes. Candidate 3 has 3 votes. 5 has 6 votes. I think we can have candidate 4 now, right? That way, or candidate 7 or something like premium. Yeah, that makes we'll call it candidate 0 rather. Okay, so this would all be candidate 0, and then we would have 18 19. We'll test for the case of when duplicate after this. First we need to just keep track of all of this, right? 21 22 23. Okay, so 0 has 6, correct? So in this case it will be 1 2 3 4 5 6 0 5 and 1, I guess, right? Because 1 has 4 instances. 1 2 3 4 5 instances. So yeah, I think this would be the one. This 1 2 3 4 5 6, we make it a 7 4 25. Yes. Okay. Okay, now we need to read this line by line, and at any point in time keep track of whether there was any fraud or not, right? Okay, save this file .txt, right? Yes. So what we'll do is name equal to name. Our intention is first step is we are supposed to read the data string by line, right? Read. So what we'll do is while first we need to open it, right? With open, right? We'll leave the path to the file, sample data slash hyphen voter let's R5. So I'm going to open it with R5, and for every line in R5 dot read lines, right? Read lines, right? Ideally we should stream it. We should not open it and do that. Streaming it is in the sense we should once. Okay, we could add that in the later part, like some other programs writing data into this, we are just pointing to the last occurrence and incrementing, and but in that sense, like keep reading the file line by line. We can do that. For now we'll just read a line by line. Once we read line by line, we need to first voter ID, candidate ID is equal to parse line. First we need to parse the line, right? Parse the line. Then after we need to add a function to parse the line. Once we get this, then what we are going to check is if voter ID in voter list, right? Like this should contain the voter ID list, basically all the voters which we have considered till now. If voter ID in voter list is except can add a custom exception, but for now we'll go with the basic one, right? We're going to raise an exception, and after we raise an exception, when we have the voter, if we find a duplicate, this is the case to handle the duplicate. Raising fraud if duplicate voter ID present, right? If not, like if it comes to this line, that means it's not in the voter ID list, which means that it's the first occurrence we're finding. So we will do voter list dot append voter ID, right? We would append this voter ID. Then upon that we would say that if candidate ID in candidate score, right? We could actually go with the default ticked from collections, but we'll go with the simple approach initially. Candidate ID in candidate ID score map. Candidate score map. It's not that. So if candidate ID not in my score candidate score map, that means the first time we are going to first occurrence of this that we are getting. So candidate score map of, right, candidate score map of candidate ID equal to 0. Then we are going to say that candidate ID plus equal to 1, right? Like increment the candidate ID by 1. Once you increment it, right, what can we have? We can have another what do you say, another like top or top candidate map is equal to, right, initially I go with the dictionary, later we'll see if we can just use a list or something if possible. If how would I know what are the top 3 scores, right? I need to check what are the, if I keep it in a list, no, okay, my intention here is to see what is the score, candidate score. Candidate score is equal to whatever is this person's current score, right? If this is one of the top 3, I have to just okay, instead of storing it in a map, let's say that candidate, no, we'll go with the same thing only. Top candidate map is equal to a dictionary where we are going to store all the candidate IDs, right, along with their what do you say, scores. So in that case, what we would do is for candidate in candidate comma score in top candidate map dot items, right? Items, right? If for all the items there, if my score of this candidate is less than my current candidate score, right, whatever that I have over here, I'll call this as current candidate score. If it is, what if it's the same ID? Yeah, okay, we need to check that also. If it is less than the current candidate score, in that case but we should also ensure that it is in the form of ascending order, no, like which are the 3 things. Okay, we would need to address that. Okay, this is still the same case, right? Okay, first step is we'll figure out how to do the top candidate map. What we'll do is, if top candidate map, the length of the top candidate map is currently less than 3, that means I don't have 3 items. I'm going to just add top candidate map of what do you say, candidate ID is equal to current candidate score. Somewhere I have it, right? Like this, so I can store this. For the first 3 I would add it, right? Makes sense. So I'm able to add this candidate score. Next, when the 4th candidate comes into picture, I need to keep track of, okay, we can actually have a little bit more, instead of going with the map, right? Because we would not know what is the order, we will keep candidate list IDs. This would be based on their number of votes that they have got, right? Right, and I don't think we need this. So what we'll do is when we have only less than 3, right, we will say dot append candidate. No worries. So next is when else, like else case would occur when there is not less than 3 items. I mean greater than 3 items. It means there is already some competitors for the candidate IDs. So what we would say is, right, after this we need to sort it, right? We need a function to sort candidates call that, and I will pass this. Okay, I will call it as top candidate IDs, right? Okay, this function is coming slowly. We'll figure it out how to do this. Okay, the purpose of this sort candidates is it will sort this list, right, based on the candidate IDs at the time of insertion itself, right? So the first position will be always the one with the least, and the last will be with the most. Correct. Yeah, so we'll store it in the ascending order. The third one would be the one with the most, right? So sort candidates, we need to write a function for that, right? So we'll have a function sort candidates, which would accept the top candidate. See, we could also just, whenever they ask us for the top, right, we could also just iterate over the entire score map, or just you call the sorted function and pass the values, the number of votes that each candidate has. But there should be a simpler approach than always sorting and returning the results, right, based on the candidate score. There are 1 million candidates, every time doing that would not be required, right? So sort candidates, what this function does is it would also take the overall scores, like candidate score map also it will take for reference, right? So, okay, we could send that. Now what we're going to say is we would have 10 in our array, where we're going to say that for candidate top candidate list if index in candidate IDs range, right? My intention here is temp would now be the one with the least, like the sorted one, right? So so what we are going to do over here is we are going to check what is the first value. I'll get 0. I will say that candidate, if candidate score map of index, right, I'll click min. Do I need a min? Right, if this index candidate score map of candidate ID of index, so I would be inherently storing the ID of the first index. I will go check if that score, right, is less than, so this would be the, I need to find the minimum of it, right? How would I do that? I would probably, how do I get that? I have candidate ID list, candidate list. I would be getting the candidate, like let's say for example this will be candidate 5. I know the value of 5 is inside temp. Okay, what we will do is we will always start with 0, 0 and 0, right? um Temp scores, we'll call that as, we need to figure it out how to do this. Temp IDs is equal to, we need to figure it out, but we'll come to it. What we do is, if for every one of these top candidate IDs, I'm going to check if candidate score at that index, whatever is the score, if it is less than temp scores at that index, temp scores, right? Okay. Mm. Oh, this would not sort it, right? I have a map which has every candidate. Okay, if this approach doesn't work, we need to stick with the not so efficient. Okay, we need to figure it out. We'll do that. So what we can do is, right, instead of doing all of that, we can always find the based on the sorted of this. So if there is a, instead of all of this, right, we could just say that let's say we were to call a function like print right, I'm going to say three top 3 candidates and candidate called as top candidates is equal to get top candidates. We need to work on a very efficient function than what I have. Is the default way of doing it is like we could have a function where we just remove this, right? Remove it, we call this get constraints candidate score. Just copy paste the name, right? Candidate score map, and then I'm going to always return I think I can do sorted, right? Sorted is a function where I can say that, hey, take the source is your candidate score map, right? Take this, and for every element in that, right, you would be taking a key is nothing but the I would need to pass a key got get, no, it will do just a get by default, right? Key equal to this score map dot get, right? And then you reverse it. I want the what do you say, descending order of which you will be the top three. Does this make sense? Correct, right? Sorted takes this function. This should also ideally looks like it should work, right? No, but the dot get will not return the key also, right? I need to do something like zip, because it will be for all the sorted elements, right? Where my items are nothing but the dot items, correct? For all these items, basically I'm just sorting it. Key instead of get be something like lambda. This would be the candidate item, no? Basically this would be the voter ID, no, candidate and the score. So C comma score to be, set this item, we call it item of 1, first element, right? And this would be inside the wait a second, where does this come now? Zip, will zip it up, and then of the zip I need the 0th element. That would be our list that we are looking for, and only 3 out of that. If I'm not wrong, this should be our result. Let's turn this, right? Candidates and print that over here. Save. Let's just run parse line, right? We need to write the function for that. Parse line. What we're going to do is here now to do line dot line equal to line dot strip line letter id comma on candidate id is equal to line dot split based on the comma, and then dot voter id dot strip. Candidate id dot strip, and hoping that this will return the parse line function. Basically I'm just reading each line, stripping it, and then splitting, and in case those have extra spaces in between, I'm just removing that and returning it, right? Let's see what's the issue. Problem Python. This is 114, let's yeah, 114. Zip object is not subscriptable. Why is that? Oh, not zip's first item we are returning the list's first item. So because zip would return back and iterate, right? 0, 5 and 1 candidates are it makes sense, right? It is 0, 5 and 1. Like at the end of the loop, what we need is for every candidate the score, right? For C in candidates, candidate score map, where do we candidate see candidate score map of C. I just want to see the scores of each one of these. Right, it is candidate 0, 8, 7 and 5. Does that match what we started with? We have 1, 2, 3, 4, 6, 7, 8. Okay. So now let's say we were to add an extra over here. Does it throw the exception saying that hey, there is a fraud? Yep, duplicate fraud detected. Right, okay. So now to come back, what are we doing here is we are calling the sorted function on the items. Each one of these candidate score map items is nothing but the candidate ID and the score. Every time when we take that score, basically this would be candidate 1 and his score. We would pass that as an item to this sorted function where we will choose only the score value, and we are storing all of those in the reverse order, right? And we are zipping those results, of which we are returning only the list. Correct? Makes sense. If we wanted to break it down and see, we could even see the what would be the result of the entire list, not only the up to 3 elements. Save this, come back, save it, come back here, run the problem again. See, we have a list where we have candidate 0, candidate 5, 1, 3, 2 would be the keys, correct? Where their values would be 8, 5, 7. So then what we are doing is we are saying that hey, pick only the first 3 elements from here, right? Like when we zip it, this would get zipped to this would get zipped to this, and this would get zipped to this. So basically we'll be having a tuple which contains all the candidate IDs which are sorted based on their scores, right? After we do this sort function over here. Correct. Correct. Okay. Of which we will be taking up the 0th entity and only up to the 3 elements. Okay. Yep, I think this should resolve this problem.